Okay, before lunch we were seeing about how to take a remote of the node, and now we'll see with the troubleshooting the application, deployment. Here I have to go through some basics. Here it is not there and actually in the text because it is assumed that it's covered in the previous DO180. So maybe one who have not done that. So for them, I just go through some basics about how to deploy an application in the OpenShift. So that's the main aim behind going for the open. First, we have to deploy the application. Then we will see about managing that application. Then we see about the orchestration. So how to manage that application using the orchestration build on that. Okay, so you will see how to deploy the application. So how we are deploying the application? So we will be now. So we'll be going to the abstract concepts. The concept in a sense like we will have a cluster. So this is OpenShift cluster. So when I say cluster, it includes the master worker as well. So combined unit, I call that as cluster. And I'll be deploying the project. So I'll be deploying the project in the cluster. So the project reference will be there in the API server. So whatever the project you are creating, the name of the project, all the references will be created in the API server. So we'll be creating a project, and inside the project I'll be creating the application, and this application is going to run on the worker node. Okay, so this application inside from a particular project is going to run on the worker node. So you have to remember this. So I'm going to we are going to the abstract concept. Like so, now we understand when I say the application is running, it's actually running on the worker node. So here in our case, the worker, the master, the same nodes are there. In the real time, the master node will be separate, the worker node will be separate. So when I say application is running, so it's actually running on the worker node. So here you will see it's running on the master node itself, but the real time it's going to run on the worker node. And the project is a reference. So project is like a isolating the different components, a different application together. Like I have two different 3 or 4 similar applications are which going to serve some common purpose. So I have the front end, back end, the other application together placed in one project, one set of project. So similar application or similar kind of goal can be achieved through some application which can be placed in the same project. Project act as the main purpose of project is 2 reasons. One is the isolation. So one is the application level isolation. That is one reason we go for the project. So it's providing an isolation for the application so that you can have different applications grouped together in a project fashion. So for just serving some common goal or common need. So that is one. Other one is we are going to do something called a role-based access control using the project. So we'll see this later on. So here we will be giving a role. We'll be giving access to the user for a particular project depending on the role. So you'll be having a role. So based on the role, he will be able to access a project. So we'll be able to give a role-based. So only if you have a project, then we can do this role-based access control. So for the user based on the project. So first we have to create a project. So for that purpose, the project serves for that purpose also. For doing a role-based access control, the second one is isolating the application together in a similar environment. So that is also through the project. So say some project is some application is running on a project. That means the application actually normally runs on the worker node. It's not that application is running on the server, so it's running on the worker node. So in our case, the worker node and the master node are same, but in the real time, the worker node and master node will be different. Okay, and so when I during the previous discussion, so I want to deploy the application now. So we learned about the project. What is a project now? Second thing is to deploy an application in the project. So what are the methods available? So when you want to deploy the application, there are 2 ways. So we have discussed in the morning. So the two architectures. So one architecture is imperative architecture. Through the command line, you can create the application. This is the imperative architecture we have learned in the morning. Another way is the declarative architecture. The declarative architecture. So where you would declare your input as a file format. So whatever resource you want to create, you would declare your input in the file format. Through that file, we'll be able to create that resource. And initially, we'll be following this imperative architecture. So later on, we'll be seeing the declarative architecture. But I think my screen share has stopped. One second. Okay, I hope now you are able to see my screen. Okay, so the imperative architecture and the declarative architecture. So now initially we'll start with the application deployment through the imperative architecture. So we are going to create the application through the command line. And what command we are going to use to create the application? So one command is the OC new app command. So this command we are going to familiarly use to create the application. There are other methods also. Not only this command you can use, there are other commands. So like OC create deployments or other commands are there, but most familiarly we'll be using this method. So OC new app command. Okay. So when I use OC new app command, so I have to provide the input as I have to provide the name, and I have to provide the something called a Docker image. So whenever I want to create an application, so when I use the OCNAP command, I have to mention the name of the application. So -, I have to mention the name for that application. So whatever the name, you can give your custom defined name for that application. Then I'll be mentioning something called Docker image - Docker image. So any application you're going to create, so you have to mention the container image. So through that I'm going to be able to create a container. So container image, I have to mention that this a Docker image path. Okay. So this is the format for the generalized format for the OCNAP. There are some other formats available for the OCNAP, but this is the format we will be generally following. Okay, you will be using OCNAP, then the name, then the Docker image. This is the imperative architecture. So declarative architecture, we'll be discussing this later on. So as we move on, so initially we'll be using, because this is easy to create the application. So declarative architecture requires some knowledge about. So initially we'll learn how to deploy it using the new app command. Then later on we'll see on the chapter number 4 or 5 we'll see about the declarative architecture. Okay, so once I use the OC new app command, there are 3 resources will be created. So once I use the OC new app command, 3 things will be created. So one is one will be deployment. So deployment will be created. Another thing, image stream. So image stream will be created, and third one is service. The 3 components will be created. So each component has one function, and so here the deployment. So morning we have discussed the deployment. So the declarative architecture, we have discussed about the deployment. So deployment is something which is the main configuration file or main declarative file or main configuration information. So if you have the deployment, I have something called replica set, I have the pod, I have the container. So the deployment will create these things. So each one has a purpose. I'll say this shortly. What is the purpose of each one? Then later on we'll learn more about that. So the purpose of deployment is for the update purpose. Like you can see, you can have something called rollback updates, rolling updates. So for that purpose, we have something called deployment. So to update the entire thing. So if you make any small configuration change, you'll go to the deployment. I will make that change that will be applied to the entire application. So if I scale it 100 times or 1000 times, it will be getting applied to all the scaled application, whatever the changes you are making. So this is the deployment's main purpose. And replica set is used for, as the name suggests, replica. Replica means something you are scaling, something you are replicating, something you are making a duplicate of that same thing. So this is what is a replica set. So here you will define how many numbers to scale. So the replica set, if you see here, can 2 means this through this file there will be 2 application created. So during the creation time itself, 2 application will be created of this. So replicas, you can later on increase that number. So number of application will be scaled. Then the pod is going to, so from here the template section is about the pod. Pod will hold the number of different containers, like multiple containers or single containers. So the pod is a collection of containers. It's called a pod. It's a management unit. So using the pod, we later on will see pod will have an IP address. So using that IP address, we will be doing some network level management. We will be exposing the application. So this is what a pod is. Pod is nothing but a collection of containers, and container is the base unit. So a pod have multiple containers. So here whatever you want to have, so if you have multiple containers, you can define the multiple container and different images. Using that you can able to deploy the containers. So this is the basic thing. So once I have the deployment, in place, so what are the things I'm having? So I'm having so this is a deployment. So this is called a box model. So deployment way of deploying the application through the this one deployment file is called a box model deployment, where I have a deployment. So deployment would have created the something called replica set. So the replica set would have been created. And the replica set would have created a pod. So this is a pod, and the pod will definitely have at least minimum one container in it, or it may have multiple containers in it. So here you can have the pod, so having containers, so one container or multiple containers underneath it. So minimum it will have one container. So whatever the model we are going to see single container pod only. So most the deployment which we are going to, so multi-container deployment later on when you go for the advanced studies, there you will see about multi-container pod deployment. Here whatever we are going to deal with is mostly like a single container pod. So one pod will have one container, which is a basic thing to do. Then later on when you are going for the advanced studies, there we'll see how to deal with a multi-container pod. So multi-container pod is the sense a pod is going to have multiple containers. So there is some reason and logic behind deploying the multiple containers. So there is some logic you have to go, why we want to go for multiple containers, that you will learn later on. So here the model which we are going to follow is one pod will have almost one single container. So we will not have more than one container. Through this, what are the examples we are going to see? We are going to see a single container pod. So now, once you deploy the application through this OSCNIAP command, you have 3 different things in place, like deployment, image stream, and service. And deployment will create all these things. So deployment will create the replica set, the pod, and pod will create the container and everything. Then we have something called image stream. So image stream which is created, which is going to take the local copy. So what are the image which I am creating? That image is actually located in the remote repository. The image stream will maintain the local copy of the remote image. So every time if I doing the scaling and all these things, I don't want to always go and fetch the image from the remote repository. So I'll have a local copy of that image in my internally inside the OpenShift. So in the OpenShift we have an internal image registry. Inside that image registry, this image stream will hold that local copy of that image. This is what the image stream. So this will be useful for like we don't want to get the application, get the image every time when we do the scaling or some operation. So we don't want to go and get that from the remote image. Already we have the local copy of that image available in the, that is maintained, or that is like you have some tags and this kind of things to fetch that image through the image stream. And there is something called service. Later on we'll learn about service. Service is a network component. The service is going to do some kind of load balancing and it's going to give access to the application. Later on we'll do that, but once you create the OCNUAP command, these things will be created. So deployment, image stream, service, and all these things will be, three things will be created. And deployment will create, once you say the deployment is created, deployment will create the replica set, the pod and the container and everything. So this is what we are going to see how to do that. And as I told, any container which you are going to build, basically it requires an image. So without the image you can never bring a create a container. So basically the application requires an image thing. So there are different repositories where you can find the image. So like qa.io, so there are other image repositories like Docker Hub, so dockerhub.io. There are different repositories from where you can fetch the image. So I'm just doing some sample. These are some public repositories, or you can say registries, public registries. You can create your own private registry also. For there you can place the image, and you can get that image by provisioning some permission. You can able to fetch an image from there. I think this is Docker. I think hub.docker.com. So I think this is one, the Docker. So this is also one of the places where you can find the image. So here this is QA registry is one of the Red Hat's registry, public registries. From there you can able to you can sign in with your Google account, or you can sign in with the Red Hat account. And once you sign into that, there you can have your own image. You can create your new repository, and inside the repositories you can place your images. So this is my repository. I have some images over here, and you can find its images, and also there are some images available for practice session. So under this repository, like Red Hat training, so under this repository, which is called Red Hat training, we have some more images. So we'll be mostly using these images for deploying the application. So there are a lot of images available. So also you can have your image on the Docker Hub also. So here I do have an account on Docker Hub. So here also you can have the image. So you can create your own container image, and how to create your own container image is out of this scope of this course in the DO180. So there they will deal with how to create your own image, how to customize your own image, how to create it, and how to manage that in the repository. Just here I'm saying that we have a repository. From the repository we are getting that image, and using that image I'm going to build a container. So build a container, I'm going to manage container. So to manage any container, first I need to build it. So build the basic things remains the same. So building the container requires an image. So whenever you are going approaching some container building engine, so that is going to ask for your image. So you have to find out where you have kept the image and how the permissions you have given to that image. So you can give a private permission or public permission. So depending on that, you are able to pull that image, and you can later on build that. Build containers using that. So these are some of the repositories. I just given you 2 examples. So you can have a lot of image repositories. Like you can even use GitHub as an image repository, or you can have Red Hat access.redhat.io. So the Red Hat itself, you have 3 or 4 repositories to hold the image. So like that you can go on. You're gonna have a lot of image repositories. And I just given you 2 examples. So either you can have, here I have some images over here, and here I have some images in the Red Hat qa.io. So here the Red Hat itself, they have provided some images for training. So I'll be using some of the images for building the application. Okay. So basically, when you want to build any application, you need to have an image. Okay. Having learned this concept, now we'll apply these concepts. So I'm going to create a project. So I have logged into the cluster. Inside the cluster, I'm going to create a project. So after creating a project, I'm going to deploy an application. So I'm going to primarily use OCNUAP command to deploy the application. So remember that not only the OCNUAP command is available, so there are a lot of ways to deploy the application. So if you are familiar with Kubernetes, or if you have studied Kubernetes or something, you might know what the different methods are there to create the application. So this is not the only method, but this is the easy way to deploy the application. So since as a beginner, so we'll start learning through the OCNAP command. Later on, when you're going for the advanced studies, when you're studying the Kubernetes, when you're studying even studying the OpenShift at the advanced level, so DO280, then you go for the advanced studies. There you will learn more about how to deploy the application with the different modes, like different ways you can deploy the application. Okay. Right. So now just let me verify whether I'm into the cluster or not. Let me do OC who am I, and I'm into the cluster. Now I'm going to create a project. So to see what are the projects are there in the cluster, you can use OC get projects command. So this command will show you what are the projects. So here, since I have logged in as a kubeadmin, so in the kubeadmin I have access to all the projects in the cluster. So there are a lot of projects. What are the projects which is starting with OpenShift. So that means that project is created for the management of OpenShift platform. So internally to manage the OpenShift platform. So we have discussed about some operators running, some application running. So that will be running inside the particular project. For example, the API server will be running inside this OpenShift Kube API project, API server project. So each project will hold the application which is pertaining to that functionality. So whatever it's, for example, scheduler will run inside this one, and the operator. So we have said that operator will be running this under the operator project. So we'll have this projects available. So these are the default project. So now I'm going to create a project, user project. Like I'm going to create a project for the application deployment, which is a user project. So I'm going to create that. So to create a project, this is the command OC new project. So name of the project, you can give any name. I'm going to give here my demo 1. This is a project name I'm giving. So once I create that project, you can see the message now using the project my demo 1. So currently my project now is my demo 1. So at any stage of the execution, so I want to check these two things. So whether I'm into the cluster, so I can use this command to check whether I have logged into the cluster or not. And next thing to check is which project you are working on. So this is very important because I don't have any clue. Once I cleared my screen, I don't have any clue which project I am currently in. So I want to know which project I am located in. So I just use this command. So this command will give me the information about which project I am located inside. So I can have multiple projects. So I should be in any one of the projects to work on. So currently which project I am located in. So if I later on want to switch project, I can use here OC project. Then I can use the project name to switch to the different project. So if I want to move from one project to another project, I want to switch to the project, I can use like this OC project, then the name of the project. This will switch you to that particular project. If you have access to that project, you will be able to switch to that. If you don't have access, you cannot switch to that project. If you have access to that project, that means you have permission to go into that project, then you can shift to that. So you can just switch to that. This is the command. So OC project, then the name of the project. This will actually switch you to that particular project. So if you want to know which project you're currently in, so just use OC project. This will show you the current project you are currently in. And this command OC get project will show you what are the projects are there, so available. So if you have full permission of the cluster, you will see all the projects. If you don't have full permission, it will just show you what are the projects you have access to. So I might maybe access to 5 projects. So only that project will be listed. So these are the projects you have access to. So only that project will be listed to me. So by this way I can know what are the projects I have access to and what are the projects, how to switch to the different projects and to see which project I am currently located. So always you have to check whether you are into the cluster, and I have to check which project you are working on. So this is very important. So after that, I'm going to deploy the application now. Now this project doesn't have any application. If I do OC get pods, the pods is an application, so I don't have any application here. Even if you check OC get all, so I don't have any application over here. So I want to deploy an application. So to deploy an application, the basic necessity thing which I told you which is required is the Docker image. So where this image is located, this image is located in any one of the repository. Any repository can be located, and provided you have the permission. So that image should have a public permission to get that. Otherwise you have to fetch that from, like, you have to do a login and you have to get it. So here I have public permission to get that image. Using that image, I can able to deploy the application. So we are not going in depth about that. If you don't have permission, all these things, this will be dealt in other course where there will be they manage the permission. So at the developer level, so we'll be discussing that. There is OpenShift development paper. So there they will discuss about how to manage the permission. So here we assume that we do have public permission. So there are other cases, other side is also there, private permission. So once the private permission is there, how to get the image which is having a private permission, how to fetch that image from there. So that is a different case, but we are not dealing that. So here we are dealing with the public image. So normally as an administrator, so we will be like we need not be even deploying the application. As administrator, our job is to manage the deployed application. All of the application will be running, so we'll be managing that running application. We'll be troubleshooting that. But anyhow, we have to see how to, at the basic level, how to deploy an application. So that's why we are saying this one. We'll see the basic level of deploying the application. So here I need to have a Docker image. So Docker image is basically located on the any one of the image repositories. So here we got a lot of images. So from here I'll just choose any one of the image to deploy the application. For example, here I want to choose this image, hello OpenShift. So I want to choose this image. So once I click this image, you can see the image things, like you can see the tags, but this image doesn't have any tags. Here you can see the information about this image. So when the image was created like that. So here you can find if you can directly pull this image using the Docker command, and you can directly use it. But here you are going to utilize this inside the OpenShift. Yeah. So here we do have the image path. So this is the registry name, and this is the repository name. So under the registry we have the repositories to hold some common images together like a container. So then this is the last one, is the finally the image name. The hello OpenShift is the name of the image. So this is the name of the registry, this is the name of the repository. Red Hat training is the repository name. Then finally I have the image name. Okay. So this is, so if you have any tags, so if you have the latest tag, you can leave the last thing as empty. But if you have any tags like the version or something, version 1.1, some version numbers are there, you have to mention the version number when you are pulling that image to particular version number. You can get a image with a particular version number. So you can, it is called tagging. So you have to mention the tag and get that image. Okay, so I have the image over here, and one more thing, like I want to confirm that through the command line itself. So do I have any tool to confirm that? So here I can manually go and check it. For example, consider my server doesn't have this facility. I cannot have the facility to go and check that image from there, from the registry, because I don't want to see that. But is there a tool to check it in a very easy way? So in the command line itself, is there a tool to check it? Yes, we do have a tool to check whether the image in the remote repository is available or not. I want to check the availability. When I want to deploy any application, first I have to check that image is available or not. Then if the image is not available, then if I started deploying it, I'll keep on getting errors like the image is not available, like that. So to do a clean installation, so always do these steps. So like verify that the application which you are going to deploy through an image, that image is available or not, that you have access to that image or not. So to check that, we will be using a tool called Scopio. Scopio is an independent tool. It's not an OpenShift tool. It's like an independent container tools. So using this tool, we can able to inspect the remote image. So this is used for a lot of functions. You can use for copying, deleting the remote images. So here we are going to use this inspect function. Inspect function, it will check whether that remote image is available or not. So if it is not available, it's going to throw me an error. If it is available, it will show me the details of that image. So if it is showing the details of that image, that means that the image is available. So through that image, I can able to create a container. So this is the idea. So here I'm going to use the Scopio. So I'm going to use the inspect command. The image is a Docker image, so I'm going to mention the Docker. So Docker format. So I'm going to mention here that path, image path. So q.io is a registry name. So this is a repository name, and then the hello OpenShift is the image name. So if I inspect now, you can see the details of the image. The image is already there. It's going to check that repository, check the permission, all these things. It will show you the details. You will show you, you will see some details about that image. So we don't have much description of the image. So but you're getting some details. So if this image is not there, for example here the same command, so I'm going to give some random image name like OpenShift 1. So with this name that image is not available. So in that case, what you'll see is you'll see an error. So fatal error, like you're not, that image is not available. So you get information that the image is not, maybe the image may be available, so you don't have a permission to access that image. So you will get an error. So then later on you can investigate about that. So why I don't have access, or why don't I have, why cannot find the details of the image. Later you can inspect that. So before deploying an application, use this Scopio tool to check the availability of the image. That is a primary requirement. And next thing, so we now verified that the image is available, and now we'll start deploying the application. So I'm going to use the OC new app command. So -hyphen name. So here I can, instead of this image, I can I will use this image, demo app. Okay, so I'll use this image. So let's to the demonstration. So this is, I'm going to say demo app. I'm going to say Docker image. The image is there, qa.io slash, this is my repository name. So you can find the image inside this, inside my repository. You can see this is the image path. You can mention, you can take this path, you can copy it and you can paste it also. So inside this one. So then I'm going to deploy this application. Now this application is deployed. You can see the creating resources. Actually one resource is missing because this image is not having any port number, I think. So service is not created. Usually the service will be created. So now you can see the deployment is created. Image stream. The service is not created because that image is not having some port number. Usually the service will be, the image is having a port number, it will be also created. So later on we'll see about the service. So now these two things like deployment and image stream is created. And through the deployment I have the replica set, pod and the container. So you can see now OC get all. So once you use this command, you can now see the deployment is created. You can see the replica set, then the pod. So the pod will, once you describe this pod, you will see the container inside this pod. So you can use OC get pod. So this will show you the status of the pod. So here the ready status indicates now 1/1 indicates that there is one container that is running. So that is ready. So out of one container inside that pod, that is ready, and that is running. Status is running. You can see it's not restarted. So the time. So how much time since it is running. And you can see the name of that pod. So if you do OC describe pod, so this will show you the description of this pod. So here you can find the description about the pod. So later on we'll learn about how it is getting IP address and all these things. If you scroll down here, you can find the containers. This is the container name. This is the container ID. So if you have multiple containers, you have multiple container mentioned over here. So this is inside the pod you have one. container. So you can see the event. So what are the events has happened? So it is actually getting that image from the motor. The default scheduler, what it's doing is it is allocating to one of the nodes. So here it is allocating to the master node. So the scheduler is doing that. After that, it is adding some Ethernet interface and adding IP address. So we'll learn about this later on. So about this part, this is a networking part. So we'll learn about that later on. Then what happens is the kubelet is interacting with the cryo. So it is pulling the image. The image is successfully pulled. Then it has created the container and it has started the container. Now you can look into all the manifest files. So all the things are like it will have a manifest file. If you look into the pod, so this is the pod. So this pod will have a manifest file. So if I want to see the manifest file, the declarative file of this pod, you can use oc get pod, and you can mention this pod name. I can use -o YAML. I can use -o YAML, the option, or you can use JSON also, and you want to see that in the JSON format. So this is the definition file of that pod. So I can say manifest file of that pod. So each resource will have a manifest file. So in the pod manifest file, we'll not modify anything because you can view that file, but pod level we are not going to modify anything. So any modification you are going to do, you will do in the main deployment file, because pod is a subset of the deployment file. So any modification you are going to do, you will open up this deployment file and you will change the modification. You will implement the modification in the deployment file. The deployment is the main file. So, but you can see the manifest file of all these things. You can see the pod manifest file. You can see the service manifest file. So all these things you can see this using that command. So now we can see the deployment. So you can see oc get deployment. So deployment is the main thing. So you can directly edit this. For example, if you want to modify some changes or implement some levels, implement some kind of changes, or do some kind of corrections. What you can do is you can open up this deployment file and you can change that value inside that file. For example, here you can see I have one pod. So I want to scale this twice. So when I want to scale it, so where I want to replace, here I want to go and change this replicas. So when I change this replicas number, automatically the application will be scaled. So I want to do that. So where I want to do that, I want to do it in the deployment file. So I have to open the deployment file and edit that value. So once I edit it, automatically the application will be scaled. So you can use oc edit. You can do oc edit deployment, and I want to do like demo app. So that is the name of the deployment. If you do that, it will open this file in the VI editor defaultly. So here you can go to the, so leave this metadata. So metadata is not required. So scroll down to the leave the metadata. Go to the spec section. So scroll down, you can find the spec section. Here you can find the replicas. So now I want to change this replicas from 1 to 2, so that you're going to see 2 pods will be created. Now I'm going to just save this file. Once I save this file, immediately it will be trigger the reconfiguration. So it's going to re-trigger the things. That time it is going to check for the new configuration. That time you will see that it has 2 replicas is 2. Now you see that now you can see 2 pods are running. So previously it was 1. Now it is 2, because I open the deployment file. I'll go to the replica set definition. So this includes the replicas definition. So I change this replica number. So what the replica, once you change over here, it will take the pod template and it will create that similar application from this template, and it will create the image and all these things are there. It will create that application again. So you can scale it. So like that you can edit the deployment file. So for example, if you want to modify the images, you can edit the OC deployment, and you can just go to the here under the container section, you will find the image. So if I want to modify this image, I can modify. So like I can modify this image and I can save the file. In case if I don't want to use this image, I want to use another image, I can directly modify, remove this entry, and I can give a new entry of that path. That will directly modify. It will re-trigger that configuration, and the new configuration will have the changes reflected. So even if I have 100 parts, it will be reflected on all the 100 parts. So this is what a deployment is. So this is later on, as we are moving on, so we'll study more about this. Okay, and now next thing is I want to interact with the running pod, or I want to interact with the running container. So how to interact with the running container? So for example, I want to, because the container which the application which is running, it has also got a miniature virtual system, like virtual machine. So it's almost like any container which you are running, it's almost like a virtual machine. Any virtual machine, you can take a remote shell and you can go and check the file system. So for doing any troubleshooting and all, how you can do that? So how you can troubleshoot that? So how you can take a remote shell of the running container? So how you can take the remote shell of the running container? So we'll see. We'll be using a command called OCRSH. Using that OCRSH command, you can take a remote shell of the running container. So like you can use OC get pods. So there is a container inside this pod. For example, this one you can do a OC describe pod. So you can grep for grep 2 lines for the containers. So the container, you can see the container name is demo app. It's the container name, and I'm going to use this container name, and I want to take a remote shell. So I will use the command OCRSH. This is a remote shell command. I mentioned the container name, which is demo app. Then I mentioned the name of the pod, which is here. The pod is demo app. This is the pod. So you can see now my shell has changed. That means I am now into the container. You can check the OS, like you can check you can just put OC/cat/etc/OS. This you can check. You can check now the OS which they are using inside this container image, which is Alpine Linux. This is the OS that they are using, and you can see the file system, entire file system of this is similar to almost the Linux file system. So you can see that this is the file system of that container. So this is how you take a remote shell of this container. So I have a pod. Inside the pod, I may have multiple containers. So I'll specify which container I want to take a remote shell. So this is -C option is required only when you have multiple containers. When you don't have multiple containers, you have, for example, you have only one container, you can directly do RSH. So you can execute this command directly without this container, without this C option. So this C option is mandatory only when you have multiple containers. So without that, I can just do like this. So I can just check this. I just do OCRSH. It will take a directly remote shell of this container. And also, instead of using this, you can also use something called debug command also. So the same debug command which you used for the taking remote shell of the master node, I can use the same debug command for getting the remote shell of the worker for that pod itself. So now you have to mention OC debug pod and the name of the pod, which is the pod name here. If you do that, it will take the it will do a remote. It will start a debug pod. You can see the same pod here. So this is also other method to get a remote shell. So OCRHS will be mostly sufficient to do this function. Also, you can use the debug option to get a remote shell. Both just the same function. So why we need this actually? So to do some kind of troubleshooting at the file system level troubleshooting of the application. So once you open the application, you want to do any file system, you want to view the files, like what OS it's running, so what is issues. In that cases, you need to require to get into that container, and you have to look into this information to do some troubleshooting. Because since this chapter is about troubleshooting, so we are seeing how we can do with different commands how we can do the some things which is not like deploying the application, that is not discussed in this section, because that is assumed that you know that concepts. But anyhow, so some of you may be new to that, so I discussed that concept. So starting from the project, creating a project, and deploying that application, all these things. So here the straight away they will go into the concepts, like so how to look into the application and how to look into the different troubleshooting steps. 1 minute. And also one more command which will be useful for troubleshooting, like OCCP command. So this OCCP command is something if you want to copy some content, like so if you want to copy the content from the local file system to the pod file system, or if you want to copy the content from the pod file system to the local system, you can use the CP command. So you can copy the content from there. So sometimes it will be required. So you need to copy some file system. So later on we'll be using that. In some use cases we'll be using the OCCP command to copy some content from the local system to the pod file system, or mostly from it will be from the pod file system to the local system. For references, I need to store some information in my local system from the pod. So I can do that using this OCCP command. You can see the different options to use it. So later on we'll see the use case, how to use it. And next thing about this is to one second, I lost my connection. Sorry, I lost a connection. Okay. So we'll see some specific troubleshooting commands. So mostly once the pod is deployed, for example, if we give OC get pods, so the pod will generate some logs. So I can view the application logs of this pod. So using the command called OC logs. So this command will display me the logs of that particular pod. So the pod would have generated some logs. You can see the log information, log messages of that pod. So this will serve some. This may give some idea about the error state, like some application may be in the error state. So this may give some idea. So why the application here it is not in the error state, it's running, but you can use this logs command to view that application. So you can use this logs command to view the application. Like if you want to limit the number of logs, maybe if the application may produce a lot of logs, you can use -- tail to limit that. So to only 5. -tail. So you can limit that to the number of logs you want to see. So you can use OC logs. -tails to limit the number of logs you want to display. So this logs command will be useful for when we are doing some kind of troubleshooting. And next troubleshooting command which will be useful for us to learn is like we can use status command. So this status command will give me information about the running things. So when you have deployed, so in a project you might have multiple applications. So this will give in a nutshell. So what are the application you have deployed? So at what time you have deployed? Now currently what is running? So how many pods are running out of that deployment? It will just give you an overview, summary of in the project if you want to know. what are the application running in the projects. Here it's only one application running, so sometimes it will be useful for you to when you're doing some troubleshooting. So what are things are running, what is not running. So what is the it just give you some rough idea. So what is here, what you required, what you requested, and what is currently being running. So you can get that information using the status command. And next is events command. So this is a very useful command for doing a troubleshooting. OC events, OC get events. So this events command give you the normal things what has happened in the project. So starting from the project deployment. So this is going to show you the events that has taken place in the project. So this events command will give, if you have any errors, you can go through this events command. There you'll find the warning. So sometimes you see the warning, sometimes you see the severity will be normal, the type will be normal. So these are the normal actions. So sometimes you see the warning, sometimes you see the error, or sometimes you see some different warning status over here. So depending on that, you can start your troubleshooting. The events command. So this will be useful for you. And final thing is using attaching a log level to the command. So attaching a log level to the command line will give you some clue about how my how my task is getting executed, or how my command is getting executed. For example, if I just use OC get pods, so what happened? This is interacting the API server and it's provisioning me the output. So what is happening at the background? If I want to know that, I can just with this command you can use something called log levels. You can attach something called log levels. You can say it is like the log level 6. It should be log level. Okay. Now you can see before producing, this is the actual output of that command. So before producing this output, so it's showing some log information. Now some debug information. So how it is reaching it. So what command is executing? It's reaching the API server and is executing this URL, and this is provisioning this result. So if I increase this level, so I can increase up to 10. So if I increase this level to 7, so you'll get still more detailed output, like before getting the result. So you can see what is happening at the background. So what URL it's executing, from where it is loading the file, and all these things. You can see that information. So what is the response, whether that response is okay or not, then it's provisioning me the result. So this will give you an idea, not only with this command, you can attach with this any command. So that will give you an idea how that command is working at the background. So you can increase the log level to 8, 9, 10 like that. So that will give you a more detailed vision on how that particular command is being executed. So this will be useful for us to when you're doing some kind of troubleshooting for the log levels. So that's also last command to learn is like getting the token. So later on we'll use this token. So when you want to generate a token for a user, so you can use OC who am I. So along with this, you can add something -t. So this will generate a token for this user. So using this token, you can create some login token so that the other user can log in using this token. You can set some expiry time. So using that, they can log in with some expiry, but that is other scope. But to generate a token, this is a part of the command they've given here. So just we learn that how to generate the token using this. Right. So with that, we complete this part. So what you have to do is so now you can start doing the lab on page number 36. So the PDF page number is 36. You can find at the bottom of the PDF. The page number is 36. So there you will start the lab. So in the lab, what you're going to do is so you will the outcome of this lab is you should be able to inspect the general status of the cluster. So you should be able to execute some commands at the cluster level. You should be able to see the number of nodes, status of the nodes. You should be able to get the log information about the nodes. So you should be able to see the general inspection of the cluster. Then the services. So the services of the pod running inside. So you can use the OC debug command to see the services running inside the worker node or the master node. So you can see that services and inspect that. So this is just an inspection. You're going to execute some command and inspect that information. and then you're going to diagnose an issue and fix it. So there will be a default project there. Once you will run this lab setup command, so at the background automatically that a script will be executed. That script will create a lab for you. So create a project for you, so that then the project you are going to do one troubleshooting. So there will be a project. The project name will be execute troubleshoot. So you will go to this project. So this is how you switch to that project. So OC project, name of the project, which is the name of the project is this is already created. So we need not create it. It's already created as a part of a script. So in this project, so you see one application OC get pods. So you will see that the application is in error state. It's not running. So the status you can see image pullback off. So this is actually an error. So error in a sense, the image is not available. So the whatever that they have defined the image in the deployment file, that image is not available. So we have to use the troubleshooting commands now. So we have to use the status command, we have to use the events command, and we have to troubleshoot this issue. So you are going to troubleshoot this and make sure that this application is going to run. And how to troubleshoot it? So issue is the image. So image has some problem. So we have to identify what is that. So we have to troubleshoot that issue. And once you see this guided lab, you will see the task. So the guided lab will have a task, and each task will be followed by the steps how to achieve this task. So there will be 4 or 5 steps. This will show you how to achieve this task. Okay, so you can follow this one and to do this task. So once you complete the one task, then you move back to the next task. Similarly, you see the task, so they will give you what is the task. So if you know how to do this task, you can directly do it, or you can follow these steps. So there will be a sub steps to do this task, 2.1, 2.2, like that, to finish this task. So like that, you are going to have 4 or 5 tasks, and the 4th task is about the troubleshooting. So fourth task you'll be starting the troubleshooting. Up to the 3rd task, you will be doing just only the cluster level monitoring. So what other things are there in the cluster, you can monitor that thing. And so you will do the troubleshooting. So you will see this image pullback of error. You will use the status command, events command, which you have learned. Using that, you will do the you will use the inspect command to do the troubleshooting. Once you find out the reason, then you will edit that deployment file and you modify that change. After that, you will check the status. Then you should see the application should be running. So when you see OC get pods, you should see the application running. Then you can finish the lab. So when you start any lab, so first thing you have to do is you have to run this lab setup command. So this lab setup command, which is over here. So this is a lab setup command. So you will use lab execute troubleshoot start. This will prepare your lab environment. So at the background, it's going to adjust the things which is specifically required for this lab environment, or it will create that things. For example, in this lab environment, I want that project, execute troubleshoot project. So that project will be created, and this is start. So once you finish this lab, so for example, I want to do this lab again. Okay. So I want to do this lab again. So because I do the configuration change, I want to restore that back to configuration so that I can perform this lab. So for that reason, they have given here at the end of this lab, you can find something like finish command. So once you finish it, it will restore back the status how it was previously. So once you run this finish, the same lab setup command, if you run the finish, it will finish, otherwise it will just restore back the condition. So whatever changes you made, so that will be restored back, so that you can able to do this lab again. So in case if you want to repeat this back, so for your self-study, if you want to repeat this back again, you can able to do that by just finishing any lab. If you typically took it, if you took any lab in the course, you can see the starting script. So starting script to prepare the lab, and finish script to finish the lab, so that you can able to do that lab again. Okay. In case if you're not finishing the lab, you can just don't execute that finish command. So you can leave this lab as it is. In case if you're not finishing on the stipulated time, later on you can do it without finishing the lab. Okay, so you can start doing the lab. So starting on page number 36. I think the PDF page number is 36. Okay. The book page number. The page number showing me 16, but always look for the PDF page number at the bottom, which is 36. So that will be universally same for all. So I'll be referring to this PDF page number, which is on page number 36. So this is troubleshooting OpenShift cluster. So you run this lab setup command, then open your lab. So I told how to create the lab and all these things. So once you created the lab, so what you will do is you will go to the workstation, open the console. That will open the workstation. So you will log in as student user. The password will be student itself. So everything will be small. So log in as student user. So after logging in, open the terminal. Then you start that lab setup command. Then you start with that work. This is very simple. In the lab, you can do the copy paste. So to copy some commands, it will be useful for you to do a copy paste. Like here there is two options to copy paste. The copy the content from your local system to the cloud lab. You can copy that. For example, if you want to copy some content, so directly, so here on the top right side you can see enable host paste. So there will be a small paper symbol over here. If you click this, it will enable the host paste. So host paste in a sense, I can copy some content from here. So from the book to this. So this one I want to copy to the, I don't want to type this one. I want to copy this directly. So what I can do is I can just select this, the PDF, right click and copy it. Then go to the lab. Here I can just press Ctrl V. That will directly copy that content here. Just Ctrl V. Don't right click and do it. So right click will not work. So I'm just copying some content from my local system to the cloud lab. So just press Ctrl V. Whatever you want to copy that on the local system. Then press Ctrl V. That will copy the content to the cloud lab. That is one option. If the option is not working, then you can go for the other option. This is a dialog box. If you open this dialog box, so whatever the contents you want to copy that from the local system, then paste that content, press Ctrl V, or you can right click paste here. Then you can send it. So once you send it, the content will be sent to the terminal. So this will just ease your work. So instead of typing a lot of commands, so you can just copy paste so that you can do the lab a little bit faster. So these two options will be useful for you. Either you can use this option or this option. Sometimes in some system this option will not work, like in the Mac systems and all, it is not working. So if it is not working, you can go for this option. Okay, so you can finish the lab and we can start back by 4 o'clock for the next section. So we have completed the second chapter, second section. So we'll start the third section. This is introduction to the dynamic storage. So do the lab. We'll start back by 4 o'clock for the next section. So any doubts?